So last time we stopped at discussing encapsulation, and what took us there is we said if you define everything as public, so your class is public, all its members as public, then everyone outside the class, all other classes, a user for example, has access to this class and member variables and functions, right? Then we said this is not safe. One reason why you may have encapsulation, and you guys should know this concept because it's very important. It's not dependent on Java. It's any other programming language that we have right now is OOP will implement the same concept, right? So it's a more of a programming skill. This is too loud, I guess. So this is a programming skill rather than being a syntax for Java. Good? So what I want you to watch is we will kind of be a little bit funny today. So we will watch this video. This video is actually from PHP. Do you guys know what is PHP? Does anyone know what is PHP? Yeah. It's another programming language, but it's web development, right? But again, it's an object-oriented programming language. So the concept is exactly the same thing. So this like 4-minute video explains why we may need encapsulation. It's one reason. There are other reasons that also we'll discuss today. So maybe I'll leave you in these 3 minutes with the video.
Employ encapsulation. So you could think of encapsulation as a container that puts things together, groups certain pieces of data together, for example. That is an object, and it's encapsulating that information. So we can think of encapsulation as keeping things together, but that's not the only thing that encapsulation offers. Encapsulation has another idea behind it. It is also what's called black boxing. So what do I mean by that? Well, by black boxing it means you just give the standard input and output. And you don't really want to know about the inner workings of the object as long as it works. For example, your television. Your television has lots of inputs that you can put into it, such as HDMI signals and so forth. And you have standard buttons that you can press and it will output certain information. Now you're not bothered about how that television goes about fetching signals and doing all the rest of it. All you care about is pushing a button and that button performs an action. As long as it performs that action, you don't care how it works. In fact, you could take the guts out of your television, have it completely replaced, and as long as those buttons still do the same thing and it still receives the same input, you're not interested in anything to do with the actual technical side of it. Well, in that retrospect, we do the same in object-oriented programming. Now you may be going, why on earth do we want to hide stuff from our own selves? We're the programmers, we should be able to access everything within the object. Well, there is a very, very good reason why you don't want to just allow any part of your program to access any certain other part of your program. Let's take a use case scenario. We have users with bank accounts. Now, a bank account has a balance. Do we want any part of our program to just modify the balance? Well, maybe not. Let's say that every time the user deposits money or withdraws money that affects the balance of that account, we want to keep an audit, a record of all of the deposits and withdrawals on that account. In this case, we use black boxing. What we do is we prevent other parts of our application directly affecting the balance. That way it will stop our application bypassing the auditing on that account. Because if you could just directly change that value, then how does your program know how to create a log and audit that transaction and audit that change? It doesn't. So what we do is we hide the balance property. It can't be affected directly. Our programs have to go through the withdraw and deposit methods. And when we go through the withdraw and deposit methods, it will change the balance, but it will also insert a record into our order.
We also allowed these methods to change things. So as a programmer or other part of the program, I'm still able to change the balance, but through these two methods. How this is different? Like, I'm still able to change the balance, right? Either by adding or subtracting something. The only difference is I just added something in between, which is these two methods. How this is helpful? Yeah? Exactly, but why? This is what I'm asking. Why? What is the benefit that I get as a system when you go through the API rather than just directly accessing this one? Yeah. Great. But then why it's more secure? Why having private variables accessed in a more controlled way is beneficial or more secure, right? So there is one thing additional specifically in this example that shows you the benefit of that, right? If I'm able as a user or a programmer of another class to access the balance directly, I can do anything without being caught, right? But if you go through these two API functions, then as a programmer who wrote this class, I can embed something in these two functions, do another step, right? This is the additional thing that you can do in the API. You have the full control of the API. So what we have done here is we added the log transactions thing, which is the auditing in the bank language, right? So anything that goes through these two functions, log as a system, which means whatever you do in your balance, we have a log for that in our database, right? But if you are able to access the balance directly without these two methods, then there is no logging for that, right? So the main concept here is going through the API, you are still able to modify the internal variables or the private variables. But as a system, I do some extra step on that. First, I give you a controlled access. The second thing is I either record what you have done or allow you to modify them in a certain way. Another example would be through these two functions, I say if the balance, and banks sometimes do this, you have, for example, a cap on how much you can withdraw in a single transaction, right? This can be coded in this withdraw method, right? But if I have a direct access to the balance variable, I can just do whatever the hell I want to do, right? Make sense? So basically the main concept of security or additional API or encapsulation for this one benefit is you are able as a system or a programmer of this system or this class to do some extra step, whether this is logging, whether this is controlled access, whether this is something, whatever you feel is important for your program, then you do it in the extra API. This you cannot do if you don't have this API and like anyone can access the balance thing. This makes sense? Yeah? Is there any question? As I said, this is one benefit of encapsulation. It's not everything. This benefit is securing or hiding certain information or controlling access to it, right? Another benefit we'll see right now. But for now, have any question? Okay. So how do we do this encoding? Is through what we call getters and setters. Have you heard this term before? Yeah? If you write in OOP, as I said, you don't, many of your variables, some of them can be public, but many of your variables, it's a good programming skill to allow access to them through what we call get and set. The very simple shape of a get or a set function is just a single line, right? Which you assign this, assume for example, I have a variable that is private here that's called L bound and R bound. Get R round, for example, is nothing other than, say, a variable is equal to my this.r round, right? So you just get the value, right? Set, you are going to set the R bound to an input from the user. So just a single line, assignment thing, right? But by doing this, you actually didn't do much, right? Because you do exactly the same thing as if the user would directly access L bound and R bound. Is that correct? Is that correct? So if I wrote L bound and R bound, forget about this for now, we are going to come into this later. Come on. Yeah, it's already there from the beginning. That's good. So if I have just done this, my question is, isn't this exactly similar to if I allowed access to L bound to the user? Just didn't do much. I didn't do any control, the thing that I was just explaining right now, right? I didn't do any extra step, any logging, any controlled access, any condition, nothing. I just returned the value directly. Is there any difference here? Let's say also the set is even more important. If I did a set by assigning set, most probably will take an input, right? Let's see, where do I have the set implementation, but okay, good. It seems that we don't have the set implementation. What can be done is exactly the same thing as this, and then just call this set. Then it takes an input that has to be double, and I call this my around. And in the set, I'll say this dot r bound equal my r bound. My font is terrible, I know, but so what do we do here? Like, I'm trying to write a set function, right? So I'm telling you this is exactly the same thing, except that because you're going to set the variable, you're going to modify it, then you have to take an input from it. This input from the user I call my bound, my r bound, call it anything, it doesn't matter. And then I set this dot, we are going to know what is this right now, but this is basically the class that you are in, right? This dot r bound equal the input from the user, my r bound, right? Now, how this is different than just allowing the user to say, like new interval dot r bound equals something, because just the user passed me already a value here, right? So again, I didn't do much. I allowed the user to change it the way he would like to do, right? Right? What do you think? Is there any benefit of having a set if it's just this spacing thing? Do I have to say it's a bonus mark to get some answer? Okay, so let's see. So the thing is the following, right? And I had this figure last time, the last minute last time. This is my class, right? And then if these are my variables like r bound and L bound, and I hide these as private, and then I only access them through the API of set and get. Only access through the set and get. So yes, the user is still able to have access to these two variables. So from a security point of view, I actually didn't do much. But there is another benefit for this that the video didn't discuss. Can anyone see what is this benefit thing here by doing that? Maybe I'll give you another Another example that may clarify, or you know what, just keep it as it is. It doesn't really matter. Okay, for a bonus mark, is there another benefit by using set and get to access these variables? Even if you didn't implement any authentication or any additional control in the set and get methods? Or from a security point of view, it's done, there is no benefit, at least for now. So by doing, yeah? Yes, but this is a low-hanging fruit. This is not what I'm looking for because it's very clear, right? And it doesn't really make a big difference. You just wrote an additional 2 functions to just set 2 variables, right? So it didn't the code cleaner much, right? So this is not what I'm looking for. Yeah. But this is related to that security thing which we just discussed by, if we just implement set and get as we have seen in the previous slide, this doesn't apply, right? Because you still give full access to the user, right? You didn't do any additional control. It's not JavaScript. So how this makes a difference? So you say by adding 2 functions, you can pass another function to the function and do something, right? Yes, but that's not the full thing. This is just one use case example, right? So here is the thing, right? Any additional input? So by doing this, we just did one thing, which is the user doesn't have access to this thing. So if you implement these 2 variables, if you use them in a certain way in your code, because the class may have other methods, have other functions, do other things, right? That use L-bound and R-bound. Don't write a class to define 2 variables and that's something on them, right? If the user does not have direct access to this, and then after 1 month of writing your class, you discover that, you know what, there is a more efficient way of writing my class, right? I can make the code better by running it like X faster by modifying the algorithm that I write in L-bound and R-bound, right? If you don't have set and get and the user have direct access to R-bound and L-bound, you cannot do this, right? Because as a user, I'm your customer, I already have a version of your code that I write all my other code based on this implementation of the class. And by having direct access to the L-bound and R-bound, I put all my code around it, knowing that I have this access, and I use them in the way that the class used them, right? So if you modify your class, I have to throw away all my code. As you can imagine, this is not the case for like a customer level code, like for an actual code that, like software you buy, right? Usually you just get updates and they work the way you should work. And between big companies, like I get a version of your code, I do my code on this, and then later if you do an update, the update has to go smoothly, right? It doesn't have, I don't have to modify everything and work for extra 6 months to modify my code accordingly, right? This doesn't work. So by having the set and get, just even if they are that simple, the way you implement or use your R-bound and L-bound in your class, because this is a black box, it doesn't really matter for me as a customer. I can still use the set and get the way you told me to use without knowing or depending on the internal implementations of R-bound and L-bound, right? Do you see the thing? So by just doing this, I'm able to upgrade my code as a programmer without asking the user or the customer to change everything. Again, because it's a black box, whatever I do inside it doesn't really matter. I have version A, version B, version C. I make it faster, better, but you don't care about my implementation. So the main benefit we get here is you are able to upgrade your code without asking the users of this class or the whole program, like as a customer, to change They don't do things, right? Because the only thing that they care about is this contract thing. This is a contract between you and the user of the class. If this is okay, then as a user I'm okay, right? Think of this like you have a black box that asks you to input a certain input and you expect a certain output, right? What is inside doesn't matter, given that the input and the output relationship is still the same, right? So it's exactly this thing. By not having this, now I have access to what is inside. So once I change it, things will change, right? Is there any question here? This is a very, very important thing. Yeah. No, this is what I'm saying. Like if you did this and assume these two variables are public right now, and you use them in your class, good? And we don't have set and get. If you change it the way you implement because your class implementation, assume you use outbound and outbound afterwards, many times. So if I change it the way I use them and modify them in my class, and the user have direct access to them, he also has to modify his code, right? Because the way he is using outbound and inbound will affect the way the algorithm works. But just by having sets and gets, the user doesn't really care how I use outbound and inbound in my class, right? I can use them the way I'd like because he doesn't have direct access to them, right? He only cares about, I want to get this, I want to set this, right? Make sense? Yeah. Is there any question? Okay. So another thing we have here is, so we had the get, L-bound, R-bound, and then the set that I just explained, but also we have another thing which we call constructor. What is a constructor of a class, right? So last time the way we define a new variable or object of that class is we said, for example, my interval, like new interval, my interval, by declaring my interval as a variable of the new interval class, and then say my interval equal new interval thing, allocating it in the memory. That's how you declare an object or instantiate a class. Good? But we didn't pass anything, right? So we didn't pass any input to this class. If I would like to set and get these variables, I have to say my interval.set and then send something or get the variable itself. Right? But if a class has 1,000 inputs, like big classes may have like very initial variables, right? If I need to define a new variable of this class and then every time I need to set all the 1,000 variables, it's like a big problem, right? What you can do instead is by defining a constructor in a class, when a user defines a new variable of this class, he can directly pass the inputs to this class. How can this be done? By constructors. What are constructors? Constructor here is just nothing other than a function, right? Or in Java language, it's a method. But it's a special method, right? And, oh, we don't have that. Here. So it's a special method, right? But why it's special? Because the first thing is a method that has to have the same name as the class itself. So the class name is new interval. The method is called new interval. So the constructor must have the same name of the class. This is the first thing that is special about this method. The second thing that is special about this method is you don't called or invoked by default when you define or declare a new object of this class, right? So you call the new interval method. For the set and the get, you have to say interval.set or my interval.get. For the constructor, it's special in the sense that you don't say my interval.myInterval. The compiler or the language will know by default once you define of this object. It's getting crazy here, like I feel. The sound is like going up and down, right? Okay. I guess maybe because I'm moving along. So, thing is, when you define a new variable of this class, what happens is the constructor gets invoked by default, right? Which means it gets called by default and takes whatever inputs you provided through this variable definition to the constructor function. So here, for example, the constructor takes A and B as input. As you can imagine, A and B can be the L bound and R bound. And by just defining a new variable that you call my interval equal new interval, then you pass these two numbers will be allocated to the L bound and R bound, right? Make sense? Good? Yeah. You can, but it's not a good programming skill. So, because the constructor has specific purpose, which is, but you can still, because it's a method at the end, which can call other methods, right? But don't do this because this will complicate your constructor. And a good skill is to keep your constructor as simple as possible, just for initializations. But what we see here for constructor is called destructor, and it's the complete opposite thing. A destructor is a special method that is called being destroyed, which means you just deallocate it from the memory. One possible implementation for this would be you free everything up, right? Any variables you allocated, maybe you initialize to zeros. Any memory you define, you just free, right? And by default, every class has a constructor that takes no input, even if you didn't define one. And it has one destructor that also doesn't have anything, but the memory in Java will be deallocated by default. Good? So even if you didn't define a constructor and destructor, this will be existing by default, right? Good? Okay. So here is one possible usage of this constructor. I define a new interval class they call n, and then I pass 2.5 and 3.5. By doing this, if later you say n dot L bound, what you should expect, should get 2.5, right? And then the right bound would be 3.5, right? Okay. Here is an implementation for the set function. The L bound and R bound by taking two inputs. The example that I just showed you was to set the L bound and R bound separately, so you needed two methods for this. This one is doing both at the same time. You just take two input. The minimum or the smaller one would be your L bound, and your larger one would be the R bound. So now, we use the new interval class in another class, which is called test new interval. Then I define my object or an instance of the new interval class, passing 1 and 1.5. This is my interval. And then if you print line here, the L interval and the R interval, you will get 1 and 1.5. By using the set, this is how you use a method, n.set. This is allowed because set method is public. You can still use it in another class, right? And then here, you use the get L bound and R bound. And by doing this, you are able to get the L bound and R bound of your NN class. So one question that I have is, why here it was possible to have one set function, but we had to have two get methods or functions? Why it's not possible to just write one get method for both L bound and R bound? Yeah, because you can only have one variable as a return from a method. How can I get across this? You can still able to write a get, yeah. Yes, but you cannot return an array directly from a function. Pointer, you can return a pointer to an array. Okay. So here I define three instances of the same class. One, I'm setting my interval to 1, 2, 3.5, 4.5. And then I told you before that you can allocate an object to another object, right? Which means both will be referring to the same place in memory. Here I'm setting an N3 interval to 0 and 1. So by printing the NN to 1 L bound, what you should expect as an output here? Yeah? What would be the output of this line? One. That's true. Or not? What do you think? Why 0? But this is changing only in N3. Why in N1 is affected? Yeah, it's written here in the comment, right? Variable NN3 references the same object as variable NN1. Remember, you don't define any new declaration in the memory if you don't use that new reserved word, right? So by just doing this, both are pointing to the same object in memory. But it's like having 2 pointers to the same variable. We had this example in C before, right? If you change it, the pointer that the value that one of the pointers is pointing to, you are changing also the other value that the pointer is pointing to because they are pointing, right? That means it will be 0. Yeah, new will be, but you cannot say NN3 equal new NN1 because NN1 is just a variable, it's not a data type, it's not a class, right? So similar here. If you try to print before doing this line, if you try to print the L bound of NN2, because NN2 used new, so it's a new place in memory, it's not affected, so it will be 3.5, right? You had a question? Yeah. Okay. So we already discussed this in C. The only thing that is good in Java is Java has its own garbage collection. It's called garbage collector, right? What is garbage collector? You remember in C we had to do malloc and then we free the memory ourselves, right? In Java you don't have to do this because any object that you no longer use by exiting a class is getting destroyed by default, right? So there is a piece of code in the Java virtual machine that frees the memory for you. You don't have to do free yourself, right? This is what is meant by garbage collector. Good. So now we have a quiz. So what you are required to do is the following. You are required to write, this is a very simple quiz, but things will build up in next lectures, right? So, and based on your request, this quiz is not testing something we have taken in this lecture. It's actually testing something that I've covered in the past 3 lectures. Good? So you are required to write a class that we call student, and then it's just a very simple thing. It only has 4 parameters. One is called the name, date of birth, year in school. It should be an integer, just 1, 2, 3, 4, 5. And then courses taken by this student, which should be an array of strings. Good? In later quizzes, we are going to build up on this. So you can think from now on, this can be kind of a tiny project. And I guess you had a similar question in the lab anyway. You guys, you have 10 minutes for that.